To meet OBD2 standards that protect air quality, new GM vehicles have various systems that minimize emissions. One of those systems is something many technicians seldom think of, until a check engine or service engine soon light brings a car in, and scan tool diagnosis turns up a diagnostic trouble code, most often code P0440. It's the Enhanced Evaporative Emission System, first used in 1996, and now expected to be in all 1998 Oldsmobiles. Hi, I'm Jim Scopolitis. Of course, evaporative emissions are vapors that escape from the fuel in the tank or during the refueling process. Here's a quick history of what GM has done to control them. The Canister Purge system, used up through 1995, has the following basic functions. It routes vapors from the fuel tank to the evaporative canister, where they're trapped in charcoal. When engine conditions are right, the Purge Solenoid or purge valve is opened, either by engine vacuum itself or by the PCM, depending on the vehicle year and model. Now, intake airflow through the throttle body draws vapors from the canister into the engine for combustion. Fresh air that's always supplied to the canister provides flow through the system. As I've said, the most recent versions of this older system are controlled by the PCM, but they have very few self-diagnostics and no diagnostic trouble codes, or DTCs, except for the Purge Solenoid. In 1996, two EVAP systems arrived which can self-diagnose for leaks. One is the Enhanced Evaporative System, introduced that year in the Bravada, the Achieva, and the 88 and LSS with the non-supercharged 3800 engine. The other system is called the Non-Enhanced Evap System in some training and service materials. We'll call it the Vacuum Switch System. For Oldsmobile, it's used only in the 1996-98 and in the LSSs since then that have the supercharged 3800. We'll look at this vacuum switch system first. Here's its diagnostic vacuum switch, which opens when there's vacuum in the system. So it opens when the purge solenoid is energized or opened and closes when the solenoid is closed. A vacuum switch that's always open suggests a purge solenoid that's stuck open. A switch that stays closed suggests the purge solenoid is stuck closed. The PCM can set a few codes for this system, but the vacuum switch system can be fooled by certain vacuum conditions, including pressure changes caused by hot weather, a clogged fresh air vent in the canister, and certain leaks or blockages in a hose. And in EPA regulations, fully accurate leak detection is a mandate. So the Enhanced Evap system provides for discovering leaks anywhere in the system, from the purge solenoid through the canister and the fuel tank, all the way to the fuel cap. The PCM checks for leaks by drawing a diagnostic vacuum on the system. For this purpose, the fresh air vent has been moved out of the canister and is now a vent solenoid, which the PCM closes only during diagnosis. Since the purge solenoid is normally closed, when the vent solenoid is also closed, the system should be nearly airtight, allowing only a very slow rate of vacuum decrease or decay. This requires a really tight fuel cap. That's why we tighten cap to 3 clicks. What reports to the PCM that the system is holding vacuum is a fuel tank pressure sensor mounted on the top of the fuel sender. It can respond to a leak as small as 40 thousandths of an inch. With data from it and from other parts of the system, the PCM can run tests that really check the integrity of the system. When it detects a problem, the PCM sets a code for it. In 1997, there are codes for leaks and blockages, as well as solenoid control, and more are coming. Before we go on with Enhanced Evap, here's a point about C&H body service manuals since 1996. These manuals need to include both the enhanced and the vacuum switch systems, And occasionally the schematics can confuse you. So remember this: the enhanced system, besides a purge solenoid or valve, has a vent solenoid and a fuel tank pressure sensor. If what you're looking at has a vacuum switch, but no vent solenoid and no fuel tank pressure sensor, you're looking at the vacuum switch schematic, which for Oldsmobile applies only to the 1996-98 and to LSS's since 96 with the supercharged engine. Okay, besides the main components, the enhanced system includes a service port for connecting a nitrogen tank diagnostic station, part number J41413. And 1998 Intrigues, Cutlasses, and Auroras have the additional onboard refueling vapor recovery system, or ORVR. With this system, a revised fuel filler neck helps prevent vapors from escaping out the filler pipe. Let's look at a few of these parts on this LSS. Here's the Purge Solenoid at the front of the engine, and here are its hoses to the throttle body and to the canister. On this LSS, the evap canister and the vent valve are located underneath the air cleaner and the PCM. By the way, on the Bravada, the canister can be hard to find. It's not up front here, but near the left rear quarter panel reached from under the vehicle. And for use with that nitrogen cart, here is the service port. The green cap always identifies this evap service port. The fuel tank pressure sensor is a 3-wire strain gauge, a lot like a manifold air pressure or MAP sensor. As we showed on the Bravada in an earlier program, this sensor is located at the top of the fuel sender on the fuel tank. Finally, of course, the fuel cap. If it's not tightened through at least 3 clicks, it's likely to cause the PCM to set code 0440. This is true even of the new quarter-turn fuel caps. Now, to do any kind of diagnosis on the evap system, you need to stay clear about how the purge solenoid and the vent solenoid work. The purge solenoid with no voltage applied is closed, sealing its end of the system. The vent solenoid with no voltage applied is open to provide fresh air for the system flow. When you use the Tech 1 or 2 to select the purge solenoid and then command it on, you're opening it. When you select the vent solenoid and command it on, you're closing it. When the solenoids are in their normal state, selecting and activating System Seal simply energizes that vent solenoid to close it. Let's review a few steps in the service manual diagnostics for code P0440. After using the Tech 2 to check the fuel tank pressure sensor at ambient pressure, you command the vent solenoid on to seal the system. Then attach the nitrogen cart hose to the service port. Next, open the tank valve and turn the rotary switch on to pressurize the system until the pressure gauge on the cart reaches 5 inches of water pressure. With a really large leak, pressure usually wouldn't reach this level. Then turn the rotary switch to hold. With this pressure now applied, again check the fuel tank pressure. The sensor should eventually reach approximately 5 inches of water pressure, though you may need to reapply pressure in several increments. If the pressure does reach about 5 inches, the next step is to determine that the purge solenoid is not plugged. To do this, disconnect the solenoid from its line to the throttle body and plug the solenoid at that fitting. Then activate System Performance. This function opens the purge solenoid and closes the vent solenoid. Next, pressurize the system to 5 inches of water pressure. Again, you may need to do this in several increments, turning the switch to hold in between. Then remove the plug from the purge solenoid and watch the pressure. It should decrease from 5 inches to 0 within 15 seconds. Those are some of the most common steps with the nitrogen cart. Now, anytime you suspect a leaky solenoid, you can try that plugging trick a different way. To check for a leaky purge solenoid, disconnect its hose from the canister, plug the hose there, and pressurize the system. If it now holds pressure, the solenoid is the obvious suspect. To check the vent solenoid, disconnect and plug its hose running to the canister and pressurize. Of course, you can also remove a solenoid and check it by hand. A good purge solenoid with no voltage applied won't let air pass through. You could check that with a hand vacuum pump. With voltage and ground supplied to it, it will allow air through. A good vent solenoid would behave in the opposite way. Remember though, you can have a good solenoid and a faulty electrical circuit to it. Now, if when you plug the system both ways, it failed to hold pressure correctly, you'd know to look for a leak, not in the solenoids, but somewhere else in the system. You could track it down by leaving the system pressurized while you listened along the hoses and fittings, using the ultrasonic leak detector J41416. Now, let's be clear. Most cases of that P0440 code, which indicates a major leak in the system, are caused not by a defective part, but by a fuel cap that hasn't been tightened, or by some improper refueling procedure, like letting the engine run during refueling, a very unwise move. So always suspect the fuel cap or refueling issues with this code. But another very common cause of the code has been a purge solenoid that's leaking, usually because it's contaminated with carbon from charcoal. Fragments of charcoal from the canister sometimes travel to this solenoid, causing it to stick in the open position. So whenever diagnostics point to the purge solenoid, remove it and shake it over a piece of clean white paper, looking for bits of carbon. If you find them, you'll need to replace the purge solenoid in the canister and remove the involved hoses from the vehicle, rinse them well, and blow them dry. That's the hoses from the canister to the purge solenoid and the purge solenoid to the throttle body. Replacement canisters are designed to minimize the escape of carbon. Now, here's one more thing. Some 96 vehicles may have PCM reflashes that will help resolve P0440 concerns. You could call TAS about this. The reference guide has one more diagnostic hint, which has nothing to do with leaks. It concerns a short to ground in the circuit for the fuel tank pressure sensor, which can set a number of codes for the basic engine sensors way up front. Curious? See the reference guide. One final point. Once you've finished any diagnosis and repair on the enhanced system, the particular code chart may ask you to monitor the code data on the tech tool while driving the vehicle until the PCM test for that code is run. And it can be hard to get these tests to run, because the PCM will run them only under certain technical conditions as required by IM 240 guidelines. But you can control many of these conditions. The reference guide explains what they are and includes a chart showing the OBD2 drive cycle, which must be followed for the tests to run. The long D cells in the drive cycle are where most evap tests occur. Technicians should establish a local driving route which will let them approximate this cycle. For more on OBD2 and the enhanced evap system, attend the OBD2 class at your training center. It's number 16030.02. Hey, it's all part of doing our job to help keep the air clean. See you next time.